In this video clip, we will look at the graph of sin x. We know sin x is defined as a y-coordinate when the amount of angle is this much. Y-coordinate of this point on the unit circle, where angle is pi/3, then we have y-coordinate is radical 3/2. That will be sine pi/3 is radical 3/2. Here is the angle value. So when x or angle is pi/3 here, and then we have a sine value, radical 3/2. Radical 3/2 will be the value y, or sine x. Sine x. So then basically down here is when you have an angle which is pi/3, then you have a y-coordinate is this high. You see they are connected. And you see the red arc length, which is the measure of this angle. So basically, the horizontal red line segment length is pi/3, and then the vertical length is sine value. Okay, that's why they are the same height. Okay, this is for pi/3. Actually, for pi/6, the angle is smaller. Same pi divided by big number. 6 is bigger than 3. Angle is smaller. You see pi is 180 degrees divided by 3 is 30 degrees. So here is 30 degrees. Previously, 180 divided by 3 will be 60 degrees. So this angle is bigger. Okay. So this is for pi/6. Pi/6. And then this will be the amount of angle from 0 to pi/6. And here the red part is the arc length, which is used to measure how large this angle is. So this red line segment, the length equals the length of this arc. This is a unit circle, so the radius is 1. Okay? Moreover, the angle can be 0. Angle can be 0. That means when x choose 0, 0 degrees, we will consider this point. Then the y-coordinate is 0, which will be the sine value. So then you have a sine 0 is 0. So this point gives us 0, 0. It's also on the picture. Okay, so we then have a 0, 0. This point will be pi/6, 1/2, this one. And then you keep going. You have a pi/3 right here, and the y-coordinate here is radical 3/2. Then you keep going. You have the angle is pi/2. Angle is pi/2. Then you have y coordinate is 1, so same height. Okay, so x is pi over 2, then sine x will be 1. Okay, so that's how we get all those pictures. Again, the line segment red equals the length of arc. Length of arc. So from 0 to pi over 2. Okay, so basically it tells us what? From this animation, from here to here, and then from 30 to 60, from 60 to 90, when 30, 60, 90 degrees, for the equal amount of movement for the angle, then we have actually y is at different position. You see that, You see the first one is 1/2 already. Then the second point is not 1, is what? Is radical 3 over 2 is less than 1. Then you move the same equal amount, pi over 6 or 30 degrees, you then get increment, which is from radical 3 over 2 to 1. Okay, so you can keep going then, like that. Okay, so when the angle is this big, the arc length on the unit circle is this long, or the angle is this big, you may say. Then you have a y coordinate of this point is 1/2 again. Okay, so you then keep going. When the point here is pi, or the angle is pi degrees, so from 0 to pi, this red length of arc is pi, or the angle is pi, so you then have a y coordinate is 0, so sine pi is 0. Okay, and then you can keep going like that. Okay, that's 1x equals 2 pi. That means 360 degrees, y coordinate is 0 again. So when x is 2 pi, then you will have a sine 2 pi is 0. That's y coordinate. And then you start over. 2 pi, keep going. Okay. So this finishes one period from 0 to 2 pi. That's why we say the period of sine is 2 pi. You see, from 0, 1 circle. You then go from 2 pi plus pi over 6, 2 pi plus pi over 3, 2 pi plus pi over 2. Okay, so it goes to another period out of this screen. Okay, at this place, we go back. At this place, the function sine x, f of x equals sine x, reaches maximal, and then it goes down. Okay, reaches hit x-axis, and then keep going. So when x equals 3 pi over 2, it reaches local minimum, which is -1. -1, and then it goes back. Okay, so there are 5 key points. The first point is the one here, and then the second point is here, maximal, third point hit on x-axis again, and then minimum fourth point, it then goes back to the fifth point. Okay, so that will be the graph. And from here, we may want to see more. Now you can see that this is sine graph. Okay, you see from 0 to 1, and then to 0, hit the lowest point, go back again. Okay, and this is actually you start from the negative pi. It goes down because negative pi and pi, they are coterminal angles. Okay, and then we know sine pi is 0. Then we know negative sine pi is also 0. Okay, so you may say start from here, negative pi, and it goes to pi. Okay, so this looks like S. From here, negative pi to pi, looks like a S. But if you look at from negative pi over 2 to 3 pi over 2, it also is a one period. It looks like a V upside down. Okay. Now, here we need to point out is that y equals sine x is a odd function. Is an odd function. Is because this is true. This is true. Okay, sine negative x is negative sine x. We have seen that before. So that's why if we let f of x is sine x, then f of negative x will be negative f of x. Is because of this one. Okay, since sine x is an odd function, the graph will be symmetric with respect to the origin. Okay, so that means when you rotate this curve 180 degrees, is going to be coincide with the original one. All right? Yeah. So you may play this one around. See right here. Okay. All right. Please review this lecture. I'll see you next.